Hello, class. In this video, I'd like to go through the solutions to Lab 2.1. This lab covers exponents, or the first part of exponents. So you'll notice questions 1 and 2 look very similar. Right? We have -1 raised to the 10, and we have -1 raised to the 21. I guess what they're trying to get you to realize here is anytime you have a negative raised to an even exponent, the answer is always going to end up positive. Anytime we have a negative raised to an odd exponent, the answer is always going to be negative. So -1 raised to the 10 or to the 100 or a million is still going to be 1. -1 raised to the 111 or 1,000,001, any odd exponent or any odd power is going to relate in the negative answer. Okay, so really think of this as -1 times -1 times -1 10 times. So if you do it an even number of times, you're going to end up with a positive value. Okay, if we take a look at question 3, we have -2 raised to the 4. So think of that as -2 times -2 times -2 times -2, and we get positive 16. That's different than question number 4, where the negative is not being affected by the exponent, right? See, question 3, the negative's in parentheses, so everything gets multiplied 4 times, including the negative. Whereas in question 4, only the 2 is going to be subjected to the repeated multiplication. So it's really -2 times 2 times 2 times 2, which ends up giving you an answer of -16. Right? So note the difference between 1 and 2 and 3 and 4. Okay? Question 5. Well, how do we get rid of the negative exponent? Remember, to remove the negative exponent, you take the reciprocal of the base. So my base is 3. So the reciprocal of 3 would be 1 over 3, and then make the exponent positive. So you're left with 1 over 3 times 3, which is 1 over 9. Question 6. Okay, here my base is 3 over 4. So the reciprocal of 3 over 4 would be 4 over 3. Make the exponent positive, and think of this as 4 over 3 times 4 over 3, or 4 squared over 3 squared, which is 16 over 9. Number 7. Okay, notice the difference between 7a and 7b. This was done intentionally. See, 7b, we're able to distribute the 6, right? Anytime you have an a and a b separated by a plus or a minus sign, and really I'm saying a or b, but really think about it as 7b, we have 2 terms, right? We have a term a squared and we have a term b to the 5th. So anytime you have a term separated by a plus or a minus, you can distribute. Number 7a, we can't distribute the 6. Right? Because we only have one term, right? The term a squared b to the 5th is one term. There's no plus or minus sign separating the two, so really there's no work to do here. It's just 6a squared b to the 5th. Where in 7b, we have 2 terms, so we multiply each term by the 6. Okay, that's a tricky one. Number 8. Okay, so there's a little note here that says, remember, y equals y to the 1, right? Anytime there's no number written above the y or the w, we assume that there's really a 1 there. So when we multiply these 2 terms, the 4 and the -9 go together. That gives me the -36. Think of this as y to the 1 times y squared. So remember, multiplication, we add the exponent. So that's the 2 plus 1 is 3. So that's my y cubed, right? And they're showing the 1 plus the 2 gives me 3. And then with the w's, think of this as w to the 1 times w squared. And again, 2 plus 1, right, or 1 plus 2 gives me 3. So here's my final answer. Number 9. Okay, let's think of this piece by piece, right? The 8 over 2, we like to call that 4. A to the 4th over a to the 4th. Well, remember, we could cross this out and just write that as 1. Or think of this as a to the 4 minus 4, which is a to the 0. And anything raised to the 0 is 1. B to the 5th over b to the 1. Well, we do 5 minus 1 to get 4. And my final answer, you could leave it as 4 times 1 times b to the 4. But most people will just write 4b to the 4th. Number 10. I remember PEMDAS, right? Please excuse my dear Aunt Sally. You do what's in parentheses first, then exponents, then multiplication. So the x squared raised to the 3rd, so that's a power raised to another power. That this time we multiply, right? That's a little bit different than this problem, right? Here we have the same base with different powers, right? The base of w, the base of w, so we add 2 plus 1. Base of y, we add 2 plus 1. Here we have the base of x squared being raised to the third. So you do 2 times 3 is 6, and that's how we have x to the 6th. Now don't forget about the x to the 4th. So when we combine these, right, same base, different exponents, we add 4 plus 6 is 10. Okay. Number 11. Okay, we have negative 4x squared times y raised to the second. So we can kind of think of this as distributing the 2 to each of these pieces, each of these factors. So negative 4 squared, x squared squared, right? X squared raised to the second power, and y to the 1 raised to the second power. And then we simplify. Okay, negative 4 times negative 4 is 16. The 2 times 2 is 4. And y squared is simply y squared. Number 12. Okay, so this is negative 2 over a cubed. You could basically write this out 4 times, right? We write this as negative 2 over a cubed times negative 2 over a cubed 4 times, or distribute the 4. And remember, the negative is being impacted by the 4 because it's in parentheses. So think of this as negative 2 times negative 2 times negative 2 times negative 2. 4 times will give me 16. And a cubed raised to the 4th power becomes a to the 12th. We're almost done. Number 13. All right, so the negative 2 stays where it is, right? There's no negative exponent touching the negative 2. The negative exponent's only touching the x. So to remove the negative exponent, we take the reciprocal of x, which is 1 over x, and make the exponent positive, okay? 14. All right, so now we have 5 over x raised to the negative 2. Remember, we can take the reciprocal of our base. 5 over x becomes x over 5. Make the exponent positive, and then distribute the 2. All right, so this is x squared, 5 squared, which is 25. And I think we're done. Thank you for watching.